Thanks, Jirka, for inviting me and well, letting me talk here. I did the XML5 thing quite a while ago, actually. It was in 2007, just after we sort of figured out how the HTML parsing algorithm should work, which is nowadays finally implemented by browsers. So I should probably tell a little bit about myself, since I'm more of a browser guy, not really an XML guy. And I know we're not very popular here, but we can leave the fighting for the panel maybe, and I can do my talk first. My background is I've been working for Opera Software, which is a small browser company based in Norway. But I work from home in the Netherlands. I'm a standards engineer, or sort of rolled into that from quality assurance. And I've been doing that for about 7 years now, working with the W3C and WhatWG on HTML, CSS. And I'm currently mostly editing the new DOM API specification and XML HTTP request. And I'm doing some research into legacy encodings. So everyone should be using UTF-8, but I've been doing research into how EUC-GP should actually be implemented, because there are quite a few minor differences and such. But today I wanted to talk about XML5, which, as I said, I worked on in the past, but it keeps coming up. I was also in the task force that was discussing the HTML, XML bridging, and every now and then XML5 comes up, and the SVG guys were sort of interested in it. So I thought maybe I should accept the invitation this time and come here to Prague to talk about it. My objective at the time was to take XML and throw away the well-formedness requirements and replace it with well-defined error handling, which is what we had done for HTML at that time. And I called it XML5 as sort of a play on, because this is what HTML5 was. HTML5 was like well-defined error handling for HTML, so I thought like maybe you can do XML5 and it could be sort of the same thing. And there were a lot of jokes at the time as well about doing a CSS5 and an HTTP5, and yeah, so it sort of played along with that theme. But the name doesn't really matter that much. This is really what it is about, to figure out how to do XML and keep its backwards compatibility and everything. But instead of halting when you hit an error, you miss an end tag or something, you keep on processing. So yeah. So yeah, earlier Jenny said, I just put this quote here for fun, that it was a child prodigy, did all kinds of things, but they had to make a choice. And I guess where it ended up now is it's not the format of choice for web developers. Like web developers, they'll use HTML to output because it's easier and more convenient. But maybe if we change XML a little bit, we can make it a format of choice, and it can grow a little bit and do some of the things it was destined to be as a child prodigy, maybe. So what are some of the benefits of taking XML and changing it? The main problem, I think, with XML today, if you look at it from a web developer's perspective, I realize that I'm talking to an audience full of XML experts, and well-formedness is not a problem for you guys, or maybe for some of you it is. But for web developers, getting all those details right, from encodings, making sure that ampersands and all those things are escaped properly, that's a pretty huge deal. And even experienced developers have attempted to do this. Like maybe some of you are familiar with Sam Ruby. He's the currently co-chair of the HTML working group, and he has a weblog called Intertwingly, where he's been, for over a decade now, has been publishing, or maybe it's not quite a decade, but he's been for quite a long time, he's been trying to publish it as XML there. So he's sending XML to the browser and trying to make sure that his think it's written in Python, that his weblog system makes sure that it's always valid in the output. And he has had a lot of problems along the way with external content that he feeds in via trackbacks and pingbacks that is in a different encoding and causes non-well-formedness errors in browsers. With problems with people commenting, bypassing certain checks he had made. So there's a lot of things he had to do to actually make sure that his weblog system was fully robust and would not cause well-formedness errors. Other people have attempted similar things with WordPress. I think Matt Mullenweg tried to make WordPress, including its administrative side, completely robust against XML, and they've gone through a lot of trouble. And this is mostly because of the way these web developers work, which is that they do string concatenation. There's not really an internal tree that they're building up and then serializing that tree. They're concatenating strings together, and when you start doing that, you need to be aware of all the loopholes in XML and make sure that you get them right in every single place. And so they work from a much more trivial level, and therefore you get these problems, and therefore XML is pretty damn hard for them. Yeah, in other words, most of these people would be called bozos by Tim Bray. But yeah, that's what the world is, I guess. I wouldn't really call them bozos. I'd call them normal developers just trying to get something done. And yeah. And I think even Tim Bray, his weblog is like had issues, and Mark Pilgrim found some errors, and people have tripped him over as well. Mark Pilgrim has similarly done research in this in the past. I guess maybe some of you remember his posts on his feed reading and stuff, and he'd written actually like a liberal feed parser and stuff. So I think that this was a goal, like, and it's not too long ago. It was earlier mentioned, like in 2005, this was still a goal, like migrating the web to XML, and Eric also mentioned it earlier that this might have been sort of nigh on impossible. And I think part of why it is so hard is because XML is such a large step. Like it's at least an order of magnitude more complicated, because you need to work with a tree that you serialize. You cannot just put a few strings together and feed it to a browser. You need to actually make sure that the strings you're putting together end up being well-formed XML, because otherwise your end user will see some kind of garbage, or will end up seeing an error message, which is not what you want. And it is complicated because the content comes from all kinds of places and is put together and is then sent off, so you don't always know what the input is. Like, I remember back in 2005 visiting a game website in Opera, and it gave me a well-formedness error because the particular game I was looking at was black and white, and they had to forgot to escape the ampersand. And this was not a problem in Internet Explorer, because Internet Explorer got the same page, but they just used a different media type. Like Internet Explorer got the page, but transported as HTML, whereas Opera got it transported as XML. So the developers were probably not using Opera and didn't even know there was a problem. And this is actually a problem that is still coming up on mobile sites, and I think .NET also gives Opera XML sometimes when it's really not quite XML. But there are some issues with it. So if we want to make migration easier, giving XML sort of the same kind of treatment on the receiving side, so that you can always process it and you can always make something out of it, at least, instead of halting and showing an error message, that would make things easier. I should really learn how to configure my Mac. Because if they are sort of the same in terms of error handling, migration becomes pretty trivial. Like you only have to change a few things in your page, and then you're switched to XML, and it might not always be well formed, but if we change XML so the processing of it will still work, and then making your pages turning them into XML pages and getting some of the benefits of XML, such as the processing is easier, it's better understood, and you can do more things with mixed content and stuff. That would be easier to add then. Because there are currently, we're thinking of extending HTML in ways as well. Like we're looking for a templating system, and doing that for HTML is really quite hard. I guess most of you are not familiar with HTML parsing, but for instance, there's a whole special section in the HTML tree building algorithm dealing with tables, which is that if you hit a table start tag first, and then you hit a div start tag, for instance, the div will not end up as a child of the table. It will instead end up as its previous sibling in the tree that eventually is created. And this is horrendous and goes back to the Netscape 4 era when they did that kind of error handling and sort of had like a hatchy patch thing. And for some reason, websites started up relying on them, on that kind of behavior, in the millions of them. And so all browsers had to copy it. And this is why the HTML algorithm is really quite ingrained with its language. And having something like XML would actually be quite useful also for making websites, because it would be much easier to add new elements in places without having to deal with these kind of issues, without having to sort out how that new element is going to work inside a table, how it's going to work if you use it inside a select element. Because all these places have like special cases in the HTML parser because of all this legacy history that we have. So that would be another benefit that we could get. So just wanted to illustrate a few of the design principles I had when trying to make this XML5 thing work. First of all, I thought it had to be, like, if we were going to replace XML in place, it had to be fully backwards compatible. So all the XML documents that you would have now would have to be processed identically. And that's not a very huge deal, but it is really important. Like, we don't really want that you upgrade your XML parser and suddenly certain documents stop working. That would be bad. Now, if you rely on certain non-well-formed documents not being parsed, that would of course be a problem, but that seems kind of a weird dependency to have, so I sort of assumed that would not be the case. Streaming should be possible. The XML parsers, XML is fully streamable. You might not be surprised to hear this, HTML is not. You need to actually, keep a tree in place because there are certain error recovery things that are really quite nasty. I think it's called the adoption agency algorithm, where you need to have a tree to do certain error corrections with, mostly with nested inline elements. Like if you have an I start tag, then some text, then a B start tag, then some text, and then an I closing tag, then things get really quite messy. And also for the case that I mentioned earlier, where you have the table start tag followed by a div start tag, you also need to have a tree because the div needs to be inserted before the table and things like that. So we don't want any of that for XML. Like if we were going to do XML with error handling, you want the error handling to be sane, predictable, and fairly easy and straightforward, including streaming. So also because you want it to be simple and you don't want to put any additional requirements, you don't want it to be schema-based. The error handling should just be based on the language itself, or just on XML. You don't want to have any schemas interfere with it, because then you get different error handling depending on what processor you use, and that would be bad. And so yeah, essentially it has to be fully deterministic. So any given input always gives the same output. This last one is also, this is shared by the HTML parser design we have now. There are some gotchas, of course. And there's actually gotchas with the XML parser today as well. Like character encodings is one, which is sort of semi-optional feature. Like if you were to use EUC-GP, you would not be guaranteed it would work in every XML parser, because only UTF-8 and UTF-16 are guaranteed. So if you use any other encoding, sort of like might work, might not. And there's another optional feature in XML currently, which is the external DTDs, which are really quite horrific. And I wonder who decided that DTDs should be in XML, but yeah. I think that was a mistake retroactively that pretty much everyone agrees on, I hope. So, yeah. I think that sort of... Are there questions so far, by the way? I can maybe... Or is that... Should we do it later? Yeah. Okay. I can just go on then. I have a few more. So I wanted to talk a little bit about the various error handling considerations. When I worked on XML5 as a project, I didn't really write a spec or anything. I wrote an implementation in Python, and I implemented an XML parser in Python, except instead of doing the checks like does this tag name match the tag name production, I skipped that and sort of went ahead processing. So for each error condition, I made a choice about what to do next. And I based my parser design on the HTML parser we had already written like a half a year earlier. And it basically follows the thing where you have the input stream, where you convert your bytes or octets to characters. And then you get to the tokenization layer, where you take the characters and say, well, this bit is a start tag, this bit is some text, this is an entity, here's some more text, end tag maybe, etc. And then the final stage is the tree building stage in a parser, where you actually build up the tree, and the tree builder gets the tokens, like gets start tags, gets pieces of text, gets a comment, gets end tags, and well, based on that, it starts building up the tree. Or in case of a streaming processor, it just hands them on. So in each of these, you have like various considerations. In the input stream, if you use, for instance, the HZGB2312 encoding, which is sort of a modal ASCII-based encoding for Chinese, it's quite old, still used. If you have a tilde, which is sort of starts the modal thing, and tilde tilde is the tilde in this encoding, in case you were wondering. But if it's followed by the character A, that actually doesn't mean anything in encoding, and it's sort of, it might be an error, it might not be. This is actually another ambiguity, I think, in the XML spec. Because the encodings, not all encodings are well defined, it is not actually clear when an encoding causes a well-formedness error or not. Like, it's not clear to me, reading the XML spec, if I use this encoding and if I had, if I had a tilde followed by an A, if that is a well-formedness error or not, because it's not actually defined in that encoding what is an error and what is not. But yeah. Anyway, we would have to sort out what should happen in that case. You would probably get a replacement character, like a U plus FFFD in Unicode. So these are considerations for the input stream. Then the tokenizer, you need to decide, do we want to deal with encoded attributes? Like what happens if after an equal sign, there's no quotation mark, but you get the letter A? Is that becoming part of the attribute value? Do we drop the whole thing? What do we do with illegal characters in tag names? Illegal characters in attribute names? What if we hit a greater than sign after another greater than sign? Those kind of things you need to decide in the tokenizer. And since we have a few minutes, I can probably show, like if I do the rest quickly, what that would look like. And then you have the tree builder. What do you do with a missing end tag? How do you deal with namespaces that are not matched? How do you deal with like a prefix that is not actually declared anywhere. And you could decide to add new features. I added a little new feature called the empty closing tag, just because it was really easy to add a new token. And so it's like smaller than / greater than, and it would close the currently open start tag. But that was just a gimmick. I can see, let me see if I can quickly show. So this is hosted online somewhere. You can find it probably from the Prague website at some point. So here's some input, and then it generates the tree below. I'll add an attribute. I won't use quotes. And so you can see that when it serializes the tree, in my design I decided to allow encoded attributes. It would do something with them. And so you get the attribute test, which has a value of test. And the S element you see has a value as a text node descendant with the value BW. And this is because the AN tag was ignored. It didn't match any open start tag, so it was just thrown away and ignored by the processor. And this is the kind of thing you would get. Like, you have to make all these decisions, like what do you do if there's an unrecognized N tag? And to show the little feature I added to XML, because it was really easy to do, then you would get this. So you see here that the B actually becomes a descendant of S, and W becomes a descendant of doc, because S is closed by this new feature. But it's just a gimmick. So it's too late for closing thoughts, maybe. So I'll just say thanks, and then we can start the panel.